Hi everyone! Today we'll be talking about equilateral triangles. Here's today's focus learning target. Given properties of equilateral or equiangular triangles, I will be able to find missing side lengths, angles, etc. In the previous lesson, we talked about isosceles triangles. Today we'll be talking about equilateral triangles. An equilateral triangle is a triangle in which all three sides are congruent. Here's an example of an equilateral triangle. Notice how there are tick marks on all three sides, showing that all three sides are congruent to each other. This means that all three sides share the same side length. So again, an equilateral triangle is a triangle in which all three sides are congruent to each other. Here's another example of an equilateral triangle. Last time, when we talked about isosceles triangles, we talked about how an isosceles triangle has two congruent sides. An equilateral triangle has three congruent sides. Let's use this property to solve for some examples. Remember to write each example down in your notebook. Here's our first example. Triangle ABC is an equilateral triangle. Find the value of x. Since we know that this triangle is equilateral, we know that all three sides are congruent. We're going to focus on these two sides. We know that side AB is congruent to side CB. This means that the side lengths of side AB and side CB are equal to each other. In this case, x is simply 7. So we can find the value of x using the fact that an equilateral triangle has three congruent sides. Here's another example. Triangle CDE is an equilateral triangle, and we're going to find the value of x. Since the triangle is equilateral, we know that all three sides are congruent to each other. But we're going to ignore this side right here, side DE, because there's no information given. So we're focusing on the fact that side CD is congruent to side CE. This means that the side length of CD is equal to the side length of CE. The side length of side CD is x minus 4, and the side length of side CE is 3. From here, we're going to solve for x by removing the minus 4. To do that, we're going to do the inverse operation and add 4 on both sides. This cancels out, and we're left with x equals 7. Let's look at one more example for this section. Here, triangle EFG is an equilateral triangle. We're going to find the value of x. Since all three sides are congruent, we know that side EF is congruent to side EG. Let me write that over here. Side EF is congruent to side EG. This means that they have the same side lengths. We know that side EF measures 3x and side EG measures 21. To solve for x, let's divide both sides by 3. This crosses out, and we get x equals 7. Whenever you see something like 3x, like we did in this example, remember that it's the same thing as 3 times x. So 3x is the same thing as 3 times x. And the opposite operation of multiplying is dividing, which is why we divided both sides by 3. So we just spent some time looking at equilateral triangles. Next, let's look at equiangular triangles. An equiangular triangle is a triangle in which all three angles are congruent. Here is an example of an equiangular triangle. Notice how it's marked so that we know all three angles are congruent to each other. Also notice how this triangle looks like an equilateral triangle. We'll talk about that at the end of this lesson. So in an equiangular triangle, each angle measures 60 degrees because the sum of interior angles is 180 degrees. We divide that by 3 congruent angles and get 60 degrees. So each angle of an equiangular triangle measures 60 degrees. Let's use this idea to solve some problems. Here's example 1. Triangle GHI is an equiangular triangle. We're going to find the value of x. And remember, you can pause the video at any time if you need more time to copy down the examples. Since this is an equiangular triangle, we know that each angle measures 60 degrees. So I know that the measure of angle G is 60 degrees. The measure of angle G is given as x plus 23 degrees. So we set this equal to 60 degrees. To solve for x, let's subtract 23 degrees on both sides. We calculate 60 minus 23, and we find that x equals 37 degrees. We were able to solve for x using the fact that this triangle is an equiangular triangle. Let's look at another example. Here, triangle IJK is an equiangular triangle. Once again, we're going to find the value of x. Since this is an equiangular triangle, we know that each angle measures 60 degrees. This means that the measure of angle K equals 60 degrees. We're given that the measure of angle K is 7x minus 3 degrees. Set this equal to 60 degrees. And to solve for x, first, let's add 3 degrees to both sides so that this cancels out. We have that 7x degrees equals 63 degrees. Let's divide by 7 on both sides. And 63 divided by 7 equals 9. So x equals 9. Let's look at one last example. Triangle RST is an equiangular triangle, which means that each angle measures 60 degrees. Go ahead and try this example on your own, and then press play when you're ready to compare answers. So we know that the measure of angle S equals 60 degrees. The measure of angle S is 2x plus 40 degrees. And we set this equal to 60 degrees. To solve for x, let's first subtract by 40 degrees on both sides. We're left with 2x degrees equaling 20 degrees. We're going to divide by 2 on both sides, and we've solved for x. X equals 10 degrees. Once again, we use the fact that an angle of an equiangular triangle measures 60 degrees. And you may have noticed this throughout the examples, but an equilateral triangle is also equiangular. So if you see an equilateral triangle, know that it is also equiangular. And we can also say that an equiangular triangle is also equilateral. This is why we usually call these types of triangles simply as equilateral triangles. So when you hear equilateral, know that it's also equiangular. And if you hear equiangular, know that it's also an equilateral triangle. Here's our review for today. An equilateral triangle is a triangle in which all three sides are congruent to each other. An equiangular triangle is a triangle in which all three angles are congruent to each other. And equilateral triangles and equiangular triangles are actually the same type of triangle. So if a triangle is equilateral, it's also equiangular. And if a triangle is equiangular, then it's also equilateral. Great job today, and please remember to submit your notes on Canvas.